Okay, so every time we have a new functional group, we'll have to revisit nomenclature. So when we look at the structure of these alkyl halides, we see that we've got a halogen, and we've got a carbon here that's our alpha carbon. The ones that, and it's attached to the halogen. The carbon that's one away is our beta carbon, and we have two of those in this particular drawing. And then this carbon that's 3 carbons away is our gamma. So we'll talk about an alpha hydrogen or a beta hydrogen. We're talking about the hydrogens that are coming off this alpha site or one that's coming off this beta site. Okay, the other structure that we need to be familiar with is primary, secondary, and tertiary. So primary halogen has a carbon that has one R group. R group is a carbon atom. So it's attached to a carbon atom here. Of course, it has 2 hydrogens here that aren't drawn, but this is primary. Secondary, as I'm sure you'll be unsurprised to find out, has 2 R groups. And a tertiary has 3. And primary, sometimes designated this way, secondary and tertiary. You'll see both designations. Okay, so let's go and do some naming. The naming is going to be very familiar from what you've done before. We want to ID the parent, which is going to be the longest chain. We're going to ID and name the substituents. Our new substituents will be called chloro, bromo, fluoro, or iodo. We'll number the parent so that these groups are given the lowest number, and then assign a locant to each substituent. We will assemble the whole thing alphabetically. And that will be, so assign the systematic name. For this first one, I've got 1, 2, 3, this one will be 4, and then we've got 5. The reason I didn't name it from the other direction, if you name it starting 1 here, then you end up with a 2, 2, and a 5. And it's better to have a 1 and 2 4s. So this thing is going to be alphabetical. So we'll start with 4, 4, dibromo. And then it's going to be a 1 chloro. And it's a pentane. Here, we could start our chain anywhere. We're going to name this carbon here 1, and it's a 6 carbon ring, so it's a cyclohexane. And we're going to call this 1 bromo, 1 methyl, cyclohexane. Okay, so here we've got a molecule. We're going to number it so that we give it the chloro group here gets the lowest number. We get 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be an octane. So I can move this up just a little bit so I can write under it. There we go. And the 4 here, we label it 1, 2, 3, 4. Then this would be 5. So we want to start at this end. And so we'll have a 4 chloro, and it'll be a 4 ethyl, and this is an octane. Because there are 8 of them. Now, there is an additional complexity here. This is a steric center. And so we're going to need to give it, whether this is an R or an S conformation. So the chlorine is going to have the highest number. And then we're going to compare carbons. And this has only 2 carbons in it, so that's going to be number 4. 1, 2, 3 on that side, 1, 2, 3, 4 on this side, so this will be 2, and this will be 3. The fourth group is facing away from us, so we can connect our 2 to 3. That looks like it's a clockwise direction, so this is going to be an R. So this is R for chloro, for ethane octane. So let's come up to this one. Here we're going to need to number this. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. It looks like we've got a chloro group, we've got ethane here, and we've got a methyl group. So this is going to be 2 chloro, ethyl comes next in the alphabet, so it'll be a 4 ethyl, and then an 8 methyl, and we've got a nonane here. Okay, now we have 2 chiral centers. We've got one here at 2 and one at 3. So we're going to need to do some, I'm going to erase our numbers so that we can assign the numbers for naming. Okay, and nice blue. The chloro group is going to be number 1. There is a hydrogen coming off at this position. It's coming toward us. It's not shown, but that's going to be number 4. This will be number 2, and that end will be number 3. So we've got something that's going counterclockwise. The hydrogen is going toward us though, so this will be an R. 2R will be in the front of this. Okay, so let's see what the designation is around the 4th carbon. 2, 3, so it's right here. I'm going to change colors so that we'll have different color to look at. So we need to determine our groups here. There is also there's a methyl group that's a hydrogen coming off this that wasn't shown. That's going to be our number 4. That's an easy one. Then we need to compare carbons. Well, we've got 3 carbons, so they're all even. So we go out one more and we look at the next carbon. We compare this one and this one, and let's see this one. And here we start to see differences. This carbon has got a chlorine attached to it, so that's going to make it number 1. Now that branch is number 1. Now we're comparing this one and this one. This one has 3 hydrogens on it. 1, 2, 3. This one has 2 hydrogens and a carbon, so it's going to be number 2. And this will be number 3. We don't pay any attention to number 4, and we go 1, 2, 3. We're going in a counterclockwise direction. The number 4 group is facing away from us, so we don't have to do any switching around. So this one's going to be a 4S. Okay, so let's number H. We start here with 1, 2 to give the chloro groups a low number, 3, 4, and 5. Now, this gives me the 2 chloro groups here. It gives me an ethyl and it gives me an isopropyl. But I can do better. I can do 3 here, put 4 here, and 5 here. That gives me more substituents. So we want to number it the longest chain, give the chloros here a low number, and give ourselves the most number of substituents that we can. Okay, so we've got a 2,2-dichloro. We've got 2 ethyl groups on 3, so we'll 3,3-diethyl, 4-methyl, and it's pentane. Now, I don't ask about common names, but people still use them. These compounds are found in DDT. Lidane is a insecticide as well, as is chloridane. Chloridane is the one they used to put around people's houses to keep the termites away. And the polychlorinated biphenyls are all examples of the organohalides. So those are all bad. These are all the toxic things, but there are also some good things. There's chloramphenicol, which is for allergies. It's a decongestant. Prozac and Splenda. So these compounds are useful as synthetic precursors. So if we start with an alkyl halide, we can end up with an alcohol, an ether, a thiol, an ester, a nitrile, or an alkene. So they're very versatile, and we'll be using them a lot in our organic chemistry. So let's look over the reactions we'll be doing. We're going to be talking about SN2 reactions and E2 reactions. We'll have SN1 reactions and E1 reactions. Let's decode this a little bit. The SN means that it's going to be a substitution. Actually, a nucleophilic substitution. That's why we have the N. So both of these are substitution reactions. The E is elimination. The numbers here tell us whether it's unimolecular or bimolecular. So if it's a 2, it's going to be bimolecular. And if it's a 1, it'll be uni. Okay? So these are the 4 reactions that we'll be looking at for the rest of the chapter.